चलो ठीक है, तो let's start with some very basic. मतलब as a subject, तो हम लोग में से कितने लोग Windows system जैसे okay, इसमें हम देखते हैं email डायरी लगी है, okay, that's many emails, okay, Mac. So, like, when you heard of this session, containerization. So, does anyone know what is containerization? No, I just asked you. Okay. Okay. And do you know any of these terms called the lecture? Okay. And do you guys heard of this term called virtual machine? Okay. Now let's start. So, welcome to Containerization 1.0. Am I clear? So, welcome to Containerization 1.0. I don't know why we have 1.0, but yeah, like the next sessions will be maybe 1.0, 2.0. We are not like it is same 1.0. So, a little about me. I'm Rahul, final year undergraduate, and I'm currently exploring cloud native tech. Do you anyone know what is cloud native tech? Yeah, it just is almost like some type of fancy word. Cloud native tech is basically technology related to cloud. The native technology that people are using right now to exploit their resources. That's the cloud native tech. So these are the table of contents, and we will discuss why does containerization exists, like what is the need of containerization, why one have to do this, and then we will go to what exactly is containerization, why are people using these containerization technologies, and then we will know how to use the containerization technologies. And I will let you know what I personally do when I want to containerize. And then we will have Q&A is question and answer session. And I am really excited for that fourth one actually, because I'm expecting a lot of questions from you guys. If you have understood the first three parts, then you will be asking a lot of questions. Else I will do. So let's start. So why does containerization exist? So there are 5 terms: efficiency, consistency, portability, scalability, as mentioned. So if I start telling what containerization properties are related to this, then you will get bored. So I don't want to go deeper onto this, but remember this stuff. I will just explain a one-word explanation of what this stuff. And after this session, till the end of the session, you will let me know why does these properties do exist in the containers. So first one is efficiency. So you all know efficiency. Can anyone quickly tell what efficiency does? Okay. Consistency. Okay. Portability. Anyone else? Okay. Scalability. Anyone else? You can just read them from there and anyone else? Yeah. There is a word called orchestration. Can anyone tell me what orchestration is? Yeah, cool. I'm happy that no one does know that word. If you know that word, then you are not this session is actually not required. So orchestration builds isolation. In COVID times, you must all have experience isolation. So, like just keep these 5 words in front of your mind and just think of these 5 words and just and let's not go wide as like how is containerization is related to these 5 words. No. So why does even containerization exist? So let's think what does people like what people have done before this containerization actually exists. Like when Bible implemented, people were using cycles, right? So when these containers were implemented, what were people doing? Can I like find this? But exactly. And yeah, we said PM and we said like the code that you want to right now if you're not using it. Like you just zip the code and just send it in WhatsApp. Like yeah, I think you should say the same thing that we said, but with a lot more lines. So my question is, what did people do before maintenance? The answer is exactly yes. So what are VMs? I don't know that. Like how many of you actually use virtualization? ठीक है. तो बाकी जो भी है तुम लोग विंडोज यूज करते हो, राइट? और एनी अदर बस विंडोज यूज करते हो. तो like do you have any like goals of using Mac? कि मतलब ऐसा होता है कि अगर पैसे होते तो Mac ही करेंगे, विंडोज ही करेंगे. So if like ever wanted like ever did you want to try Mac who are using Windows? You and plus कोई और भी कर सकते हैं. So like maybe explore any solutions. मतलब student और वगैरह. Did you try actually using Mac software in Windows? No. Yeah. Actually, using Mac in Windows is also with this virtualization. So what basically virtualization is? It virtualizes the things as simple as that. But what it virtualizes? So what are your system resources? Hardware. What exactly hardware? Your RAM. Yeah. So hard disk, RAM, network. These are all the inputs that you do into the system to work. Right? Any questions? Or any other thing that you want to add? No. So, like, these are the system resources that we will be virtualizing. So, we will give the system a formula, like the dummy RAM, dummy hard disk, dummy, and everything. And you will get it working. क्योंकि उसको नहीं पता, क्योंकि हम मतलब हम बात कर रहे हैं, उसको as a ऐसी लगेगा कि that system has something that like real hardware. So that's the like beauty of virtualization. You can virtualize anything. You can virtualize the hardware. So like before virtual VMs concept came into it, like what were people doing? Like we were at Python, we came to something. And what did people do before something? See, your booking is running the novels at a time. They are shared in your time. I mean, at one point of time you are using Windows and another point of time you are using Linux. But at a time you are using only one Linux. So that is not context of using machines. Like how are they using machines efficiently? So let me tell you, before there were no servers, do you guys have ever seen servers? Like the data centers? Yeah. How many want to see you not seen? Like there's so many phones and Google servers and data centers. Karma, then you will know what the server is. Let me just. So this is an example, like the real server. So you can see like there are many servers here. So this is an example server, and you have like the two servers here. This is one server, and this is one server. So like and beside you have the normal build CPU that you have usually seen in your office. So the right side one is actually a server, and it has like so much power. I mean, in terms of RAM and in terms of hard disk. So you have some like 1 TB RAM, and you have some maybe like 3 TB hard storage. Like you have that hard disk slots where you can insert this. So like an interesting question. So you currently are using 8 GB RAM, maybe, and 5,000 SSD or 1 TB HDD, and it has one like 1 TB RAM that burns fast storage. Like, do you think that that system is very speed and like very faster than your systems? When like the server which has more RAM and more hard disk, do you really think that the server will be basically fast? I mean, if you just launch the Chrome, it will just boot in 1 second. Exactly. It depends on the processor. So your processor is the main thing in your computer because that's where the operations are being handled, the processes are being handled. So if your processor is a like cheap processor in that server, then that server has only resources but powerful. So if that, let's say, if you have the same processor that you are using in laptop and have it there in that server, do you think that the server will be fast? Well, any other opinions? Only these three guys are giving. ये कोई class नहीं है, बोल सकते हो fast. Yeah, exactly. So that since you have the same processor, you can have many processes having that like you can that process can replace RAM now. So RAM is faster memory than your hard disk. So everything will be loaded much faster than the one that's computing to the RAM. Since your process is same, like you can handle as many processes your system is handling right now, but the processes is fast. So the processes gets completed faster, so it can accommodate more processes. In that way, it's faster. But since like if you don't have that process of the process, then it is almost same as this. So let's get back to virtualization. So I'm talking about the era where the servers are not. Like, what do you think that people were doing there? Yeah. Like, actually, the interesting fact is they were using these laptops this is called as commodity. So where laptops at that time there was market phones and small Windows XP PCs. So that PCs are actually being used at the data center right now. Then people got to know that since this commodity hardware cannot handle many processes, like if your application has very big user base and you are getting some huge user load, then the server, like your commodity hardware will just get blocked and then will just get shut down. So they started designing powerful systems. And after they designed powerful system, still the problem is not solved. Why? Can I think of this? See, like you have like the people development service. Now we have more power, like bigger processor and bigger RAM and bigger values. Now you have everything big and it is not even comparable to your system. It is very big. But still the problems are the same. If you want to have a huge user load, then that's the way. Like, yeah, it's partially correct. You have increased user load, then what? Like, why it is not efficient? Yeah, and any other good reason. Actually, like the thing is, uh, these processes are like just random things. So they have some more number of applications in their systems, and like they use it to interfere because when one application is having more load, then it had to minimize the other application's load because it cannot handle more. Since like wherever your hardware is limited and it's not limited anywhere. So like whenever the user load is increasing, they can't get just a new server and keep the power and deploy and like keep memories in it and deploy all the applications in it and then they can also use the system. Since it involves a lot of they were not doing this. And their systems usually get fucked up. And that big systems, whenever they get like clogged, it takes very large time to boot again and then they start services. So this was the problem with the normal service. Now, how does virtualization solve this problem? How does like the concept here of virtualization? Do you think like this virtualization solves this problem? So basically, virtualization will not also completely solve the problem because wherever you go, the hardware is limited. You cannot have this unlimited software. So wherever you go, this problem still persists. But what problems virtualization solve? Can you think of maybe some scenarios which were not solvable in that last scenario where you have just servers? Now you have servers with virtualization. You can have like, many voices in that same server, many like tiny blocks in that server. Do you think that this new scenario can solve any of the problem? Exactly. his point was to isolate the apps where like some apps may require some libraries that are only present in OS. So that problem is solved, and any other problem that you can think of. Yeah, some OS are right, so some OS are fast basically. If you have the same process, then the operating system that you are using will change how much performance it is giving to all of you. Right? This is one function. And any other things. You can just remember that last 5 minutes. Which points does this virtualization software scalability? How? Your name? Your name? So, yeah, that's a good point. Scalability. You can create VMs automatically, right? You cannot create a server automatically, but you can create a VM automatically. So if my user load is increasing, then I will create more VMs that will solve this issue. And then if there is no user load, then I will delete that VM. And the leftover space I will use for some other applications. Right? This is a good thing that virtualization gives. And scalability in the isolation of portability. How does like he solved like he created a web application and he's running in his own system. Now he wants you to run that application. Then how will this virtualization help you in this thing? Like simple scenario, it's not that complicated. He's working in his Windows laptop, and now you have Mac. So some libraries were not working. So I mean, when you try to do that setup, that thing is not working in your laptop. So how do you use this virtualization to get out of this scenario? Now, he has developed something in his Windows laptop, and you have Mac. Some libraries are not present in Mac, and when you try to install it, it somehow gets failed. Now what you will do with the help of virtualization? Okay. And like he said that he will use the working box and he will use like create the Windows machine in his Mac laptop, and he will do all the things of installing the software again, and then we finally get that application working. This is one solution. Okay. Anything that you like this does not get the essence of portability. Like what does portability mean? Easily transferable. Like you have to transfer this whole thing to your laptop. How does that work? Not that complicated. Simple, as if you don't have internet. So the thing is, he will create VirtualBox with the same noise he will be using. And there is this thing called snapshot. Does anyone heard of this term snapshot? Yeah. Yeah. Exactly. So snapshot is basically the whole configuration that he was using in his laptop. So like snapshots generates an image that you can use to get the configuration that everything that he's having. So more image to use this and then you will just run it in your laptop, then it will be working. So that's the portability that virtualization brings. So thoughts? अब पता चलता है प्रोसेस चल रही है Any doubt, any question? No. Okay. So now consistency. Anyone from this side? Consistency is basically having your things across OS. So consistency is simple. You will just use virtual box and then do the stuff in that virtual box. Now you get consistency. Basically, consistencies are defined like this. So different across OS means your underlying operating system is maybe different, but it should work somehow. You can use virtualization or any other technology. So in case of VirtualBox, you may tell me that we are using the same OS. I am also creating the same Windows OS that you are using. But your underlying operating system is something else. It can be Mac or it can be Linux. But since the underlying OS is different, it can be called as consistency. And it can be said as like the same thing is working in multiple codes. And efficiency, you all can guess, right? So now you know why virtualization, right? Now here is a like great example that I came across today about VMs and containers. So can you all read that? VMs are basically like having separate points, like you know Legos, building blocks, achievable. So with Legos, you have everything. And if you are selling that thing to anybody, I mean, you just have a house now, and there is a person in it, so that is a VM. You have already pre-built configuration, and you can move that anywhere you want. You can give it to other friends or anything that you want to do. But assume you are having the building blocks, the Legos, and with Legos you have built a house, and you can easily transport. Now, whenever you transport, you don't have to like build the house and then transport. You will just basically dismantle it and create instructions of how to rebuild that same house with that Legos. Now we will just transport that small bag of Legos instead of like transporting this much big house. Right? Now you get it. Anybody have any confusion in this example? So basically, the VMs are the like pre-built configurations and pre-built tools, and containers are basically the small building blocks of the system. So now you know the VMs and containers difference. So what do you think that containers are really gonna help us? Like अभी इस एग्जांपल को देख के पता चल रहा है कि मतलब कंटेनर बहुत अच्छा चीज है, क्योंकि these are just the building blocks and you can transport it easily, right? किसी और को कोई और ओरिजिनल की मतलब VMs are better than containers. Actually, like this example is just to tell you that containers and VMs are different. It's not like the containers are always the best. I will give you some use cases where VMs are better than containers. So I'm asking you that, like, कोई situation ऐसा जिसमें VM बहुत अच्छा है than containers. I think कैसे? कंटेनर भी ऐसा हो सकता है, तो कोई पब्लिकली पोस्ट कर दो कंटेनर उससे ऐसा कर लो ऐसे कोई छोटा सा हाउस बनाया and you have to transport it. तो ये जो बड़ा हाउस है वो ये है and तो उसके अंदर जाके कुछ भी कर सकते हो. But if you give your bricks and give you the instruction manual of how to build this, then these are the bricks are the containers. Now you will get the whole thing with that bricks which are containers. But if you give the whole this pura house, then it's a beam. Stop. कोई केस where VM is better than containers. Yeah, so that's the point. So basically, ये क्या है कि how did we come to this conclusion? Yeah. So like all of you bought laptops, right? Instead of getting the piece of hardware, why didn't you get the motherboard, the RAM, the hard disk, and तुम भी connect कर सकते थे, right? कर सकते थे. But you always have bought laptops. Why? Portability तो उसमें भी है. Like hard disk and RAM and तो तेरा लैपटॉप का जो स्क्रीन है, सब लैपटॉप का पार्ट्स लेके आया and तू बैठने लग गया उसमें. Versus buying the laptop is like laptops correctly as you know first right. So why did you like directly buy the laptops rather than buying the hardware? I mean the motherboard, the RAM, the hard disk, ये सब separately मतलब खरीद के why didn't you assemble it?
For the convenience, because we would have to install all the components and assemble it together.
Exactly. And anything else?
Save time or no time.
Lot of time, yes. So yeah, so yes, that's very true. So some things might be very difficult to build. So you choose VMs rather than containers. Currently, जो भी public clouds है, वो सब VMs use करते हैं and not containers because it's very easy to create a virtualized machine and a container. And like there is something like some disadvantages in containers that are like if you have a Windows system, then you can only create Windows containers, and if you have Linux system, then you can only create Linux system. When you are recording that easiness, you have to like so this is the main reason why VMs are like better than containers, and you cannot create multiple OS containers in your host. I mean, yeah, now you get it. Like if you have Windows, then you can only create Windows containers because the underlying processes जो भी वो container पे run होते हैं, they use your host processes to manage the things. Okay, so that basically totally depends on host, but you will be creating an isolated environment and you will be able to extract the configuration things that you are running. So basically the container का frame में जाता है and if anyone else is having the same OS, then तो वो container में इसको pass कर लेगा, then it will be the same. This is the thing. Windows container in macOS, it is what do you think? Like just
Like, since it is a window of operating system, so
yeah,
it should be possible to implement it.
yeah, exactly. So his problem has the solution. Yeah. So that what he said is he will create a container in the virtual machine. So he's running Windows. So he will just like create the Windows container and he will use the virtual machine to get that Windows machine and then he will run that Windows container. But yeah, it's very possible. But it's a management overhead. Basically, you are using a lot of resources just to run that container. It is a possible thing, but it's not a practical thing because it doesn't give you any advantages. Like if you don't just want to run the thing, but उसके लिए इतना करके कोई ready नहीं, and I mean it's not a practical thing. It will use a lot of your resources. Virtual environments and containers. So basically, virtual environments are just your related to environment. So if you are using Windows and you have this Python, you are using 3.8, you have created a virtual environment. Why? Because it doesn't want to like get interfered with the other Python packages. Now you are using Python 3.8 and you ship that same environment to Python 3.10, you may get errors, right? Right. So that's the thing between that's the difference between the containers and your virtual environment. In containers, you will use the Python 3.8 and then it will run. Right? So, like, is it good to use virtual environments in containers? Why? Why will your packages update if you are running a container? You have all everything free. The question is, why to use, like, should we use virtual environments in containers? You know what is the difference between virtual environments and containers, right? Does anyone don't know? So basically, virtual, like let's take an example. You have Python 3.8. Okay, so you have created a virtual environment where you have installed some package. Now that package may exist or doesn't exist in your total system, your Python 3.8 environment, but this package in your environment will not interact with your normal package outside. Okay, this is a virtual environment. And now container is different. So if you are having that same environment in Python 3.8 and you want to pass it to your friend who is having Python 3.10, that package may work or may not work because your underlying system is different. So that package may or may not exist in Python 3.10. So that's the virtual environment. And now in containers, you will fix the version of Python when you want to create it. So you will fix the Python 3.8. So even though you are having the Python 3.10, you will be able to run this application because your container is using Python 3.8. Now everybody get it? Now you get it. So now the question is, do we have to use virtual environments in containers? Is it recommended or not? Or is it just like an extra step? So what his previous response was to, if the container is using some base or anything, so it will, if it will get updated, then it will interfere with the pipelines. It's correct, but a lot of times containers doesn't have internet. Like if you want to create a secure system, resources, whatever is required, the containers locally. So, but it's if you have an internet in your container and it may have some pre-built packages which will auto-update those when it will get interpreted, and then any other things that you can think of. So anyone else? So yeah, I mean it actually depends on your configuration. You can have virtual environments in your VM, but it will be like most of the times it is like an extra step that you will do. But most of the times, as a general phenomenon, you use very lightweight packages of any OS in which there is no such thing, like no such package related to auto-updating OS or anything like that. So most of the times people don't create virtual environments in the containers, but you can create. It will be only just a different file system you will be having and you can. Now I like everyone does get both containers. So let's go back to this again. Does container support of this? Does anyone have any objection with any of the things that it will be not present in containers? So you will have efficiency, right? And you have consistency. So efficiency is there, like consistency. Let's talk about consistency. So basically, if you are using some tools for containerization, example in Windows, you have this thing called Windows subsystem for Linux. Do you guys heard of this term? Yeah. So Windows have a subsystem for Linux. I myself consider that this is the best version like taken by Windows to support Linux. So you can actually run a Linux hypervisor in your Windows. I mean, you will get a Linux system which will don't have a graphical user interface, but you can have like the Ubuntu server configuration in your Windows. So that system is used for creating containers in Linux. And since macOS is a Unix system, you will have no problem in running the Ubuntu container in a macOS system because the underlying kernel is like the almost same, and the extra things that happen, that like the extra changes will be taken care by your tools. So basically now you can run any container in any ways. Now you have consistency and you have portability, right? Any doubt in portability, and you have scalability. Of course, now you can like very easily create containers whenever it is required and whenever it is and you have isolation, which will Windows container running in macOS is not good. And like Windows like recently announced the containers. Before there were no Windows containers, but recently after Windows 10, like when the Windows 11 was released, I think they announced Windows containers. Now you can create Windows containers, but you cannot run them in Mac and Linux. Since Windows is a terrible software. So now you know what is containerization. We had virtualization and we went on to VM and then we went on to containers, right? So this is the like, classic definition of containerization. So the containerization term is basically technology and you have different tools for like having this containerization technology, for using this containerization technology, and then you can now play with containers. So take a look at this. There are two different pieces of code. Can you just quickly tell the difference in the code? So left one is Linux or Mac, and the right one is Windows. Now, assume there is a company and there is a developer who is using this piece of code. Now, let's assume that he is using Windows. Now we have written the right side. This will obviously not work in Mac and Linux, right? Since the file path is not in the connection of their operating system, the others will not be able to run this piece of code in other operating system. Now do you think that the container solve this problem? Do you think that this problem can be solved by containers? Yeah. So now I get that you understood the containers, and this will be solved by containers. And most of the companies do the same thing. They just develop the code and they ship it to containers, and then the code will be tested there. So now the problem of the thing working in a single machine is solved with containers. So this is the whole concept of containers for getting this consistency, efficiency, etc. So here is some random fact that there is a survey by distribution, and here are the metrics that why people use containers. Now I want you to tell which percentage you are in. So you are in that group of 23% people, I mean the blue, red, yellow, or the pink. Is it visible to everyone? So basically the blue is not visible to me also. So basically the blue is the developer said that it is easy to test the software in containers. It's blue, and the red is so the testing is made easy. Red is the testing is made easy. Blue is the testing is made fast and easy. And the yellow is the issues related to the different OS, you can say, for now. And the pink is there with yellow. Now you get the pink is scalable, and 10% is the consistent issues with the OS. And the red is you can easily test your code, and blue is you can test the code fast. So which color you are in? How many people are in blue? Blue is testing code faster. Blue, red, okay, and yellow, okay, pink. Cool. Now I get that the service is actually correct because the results are same results. This is the final thing, how to do containerization. The basic containers you can create in a Linux system or a Linux containers. They are nothing, you can just create a virtual environment types. They are just simple LXCs, and you will get access to the shell. You will get whole the OS, but it will not be not easily portable and easily it is not consistent. Basically, you can work with it only in Linux. Now you have Docker. So Docker is a tool for creating these containers and managing these containers. So in Docker you can create any number of containers, and you can know what containers you have created, what images are there, and etc. And there is Kubernetes. So Kubernetes is basically the orchestration tool, and show this picture. So the left one is LXA. So if you have the space, then you will be able to see that container. And in Docker, there will be some less containers. You will be managing some small things. And with Kubernetes, you will have that the J containers with lots of containers. So now you have this problem that when you want to create containers, when the user base is high, you want to create containers, but who will implement this logic? When the user base is down, you want to down the containers, you want to decrease the number of containers. Who will be handling it? Who will be scheduling them? Who will be exporting the information that each container contains what, right? So assume that this is the shape and you have lot more containers. Now you have to know what container is what and which container what you have to hand over it to which container, right? So that's the issue that Kubernetes will solve. This is basically called the orchestration. Orchestration is basically managing the containers. So the word orchestration is meant by this. And the containers and these things actually came from the ships. So this name was actually came from the ships only. And this Kubernetes, if you know the Kubernetes logo, it will be the steaming of the ship. So this is the whole analogy between these. If you get any difference, if anyone asks you the difference between Docker and Kubernetes, you can remember this analogy and you can simply answer. For this, that big ship, you have some master who will be handling all these things, when to move, what container belongs to which application, and how are these containers interacting between themselves. If you have a small application which involves front end and back end, now you want the communication only between the front end and back end, and now users can only communicate with the front end, and there is no need for them to communicate to the back end. Now, how are you going to handle this? How are you going to handle this networking part? You have to make sure that these two have the connection, but the only user should have the front end. So these problems are solved by Kubernetes. So basically, Docker cannot manage more containers. It cannot handle these things of automatically scaling the networking part cannot be handled by Docker. It is a tool just to create containers and manage containers. Just to list the containers, just to create the images and run containers from images. So basically, this is Docker is only a tool. Now Kubernetes is the tool for managing the containers. Now, how many containers do you want at what point of time? Do you want to scale or what do you want to how you want the communication in between them? Or how is managed by Kubernetes? And this is the process of creating a container. It's a simple container. Create a file. So whenever I have told you the instruction manual, if I have given you a labels, then with the instruction manual, then you can build a house. So that instruction manual is basically referred as Docker file. So in Docker file, you will write what all you require, and with that Docker file, you will create an image. So it's basically a thing which contains all the package software, and you will just execute that software to get your container to the isolated environment, and that package software doesn't contain any OS libraries that your OS will be using. You just contain the libraries required for your application and the smallest finest part of your OS that will be required by this application. Now I can tell you how to create a container. I could conduct a hands-on session, but I didn't, because I want you to explore how you will create containers and how will you create images. If this session was fruitful, then I'm sure I will to your master and then you will related to this part. So I hope you have some questions. Anything, कुछ भी पूछ सकते हो. But given the time, let's do it. Focus. Opportunities. Basically, this is a vast community. Like the Kubernetes was made by Google, but it was made open source. Like I think one of the best solutions by Google actually, because when the Kubernetes became open source, everyone started using containers. Before, people were not using Docker because there was no system to manage the containers. Like you can create containers for fun, but if there is no system for managing, then it will not work then. So Kubernetes added value to them, and then now people are like making these cloud native technologies. Now you can also like there's this thing called Kubecon. You can also create virtual machines with Kubernetes. People are developing these things after like the Kubernetes came to picture, and now this is a vast community. And like companies are like looking and already adopted these technologies. So like a cloud engineer has a huge demand. So basically, whoever knows the cloud native stuff and whoever want to learn the cloud native stuff, I recommend you to go to the communities and see like what technologies are coming in. And if you feel that you can contribute, definitely contribute. So bringing like giving back to the source is an excellent thing, and it's a very good thing that you can do as well. And it adds more value and it solves you from all the developers. See, like this is an interesting point. Like he was asking why containers are efficient. Like the VMs are also efficient if we in that scenario. Why like containers? Why just can't if the containers are the processes running in the host OS, like why should we even have containers, right? So since there are no processes in containers, so the reason we this thing why containers exist with efficiency is when you create a virtual machine in VirtualBox, if you give a 2 GB RAM, then it is statically allocated. That means if you created a 2 GB RAM of virtual machine in your 8 GB RAM laptop, that 2 GB is dedicated to your VM. And like now there is a option to allocate dynamically also, but the hard disk is allocated statically. Like if you give 30 GB to the VM, then that 30 GB will be full in your host operating system. And even though that 30 GB is not fully occupied, but it is purely dedicated to memory. And if your system has, if you allocate some 2 CPUs to your VM, then it will be your physical cores in your hard. That means if you have 6 cores, that 2 cores will be dedicated to the VM, even if the VM is not running. Okay, so the resources in VMs are statically allocated, so you cannot use them here by your host operating system. Like host operating system will get to know that, will think that the VM cores are being occupied by other processes. So now in containers, nothing is statically allocated. Everything is your OS, but they are isolated. So this brings the efficiency in using. So if you have 2 VMs and you are using only happen? The resources are not being used efficiently. But if you have two containers and if you are using them, then the resources will be used, and if you are not using them, the resources will not be used. That is the efficiency that is being brought there. The storage is always statically allocated, but so that's why the virtual storage comes with this. So like you will some virtual storage of 35 GB or something to your virtual machine, but it is not actually 35 GB, but it is something less, and it is managed by the virtual. Your OS जो मतलब उसका होता है some 10 GB, 14 GB is dedicated to the virtual machine. Now, any doubts? It will be interesting question. Anything else? So like yeah, area like if you are exploring cloud native tech, you will automatically get to know what all you will need to achieve that stuff. Amazon and AWS, yeah. Actually, I wanted. Actually, you can learn about Amazon, AWS, GCP, Microsoft Azure. These are all the public cloud services that use virtualization concept to give the resources to everyone. They are having the resources in their data center and they are distributing to everyone and they are charging for it and selling them. So these you can learn about those things. There is nothing wrong in it. But as long as there are two sides of using cloud, using as a user and using as a developer. Like if you want to get into cloud, then you have to get as a developer. You have to know stuff and you want to develop stuff, then you will go to the other side. But if you just want to use the cloud services, then you will go there to this as so like after this session, this session is as component. Know like how many of you are willing to like actually create the content. ठीक है मतलब अगर इतना लोग को इंटरेस्ट है तो मैं टास्क दे ही देता हूँ तो ये तो छोटा सा टास्क है like you just have to create a hello world web application in any framework you can use Flash, Python, Java, Node.js, anything yes a hello world page should be there and you have to the second step is you have to dockerize it. So you basically have to create a Docker file and create an image and push it to Hub. So what does Hub mean? So Docker created an interesting thing called Docker Hub, where everyone can post their image. So now you have created a Docker image of some complex application. You can just push it to Docker Hub and then you can like everybody can use that image to build a container. So basically it's a collection of the images and Docker files, the instructions and so and be safe, like be cautious that if you are using some random container, it may have malware. So it is always better to use Docker files and understand the Docker file what is there, and then you can just use. And there are also some verified vendors which will provide this Docker images. You can download from them. There is no issue. And the fourth last thing is to just send us just create a Docker image of the sample hello world application and push it to Docker Hub. Post your Docker image there and then give us a link of the Docker image. We will run it and we will check what we have created. Okay, any doubts? ठीक है, thank you for listening so patiently. ठीक है, जा रहे हैं.